Hello, and welcome to our Introduction to Programming with Python tutorial. In this lecture, or in this series, we will dive into Python, a versatile and powerful programming language known for its simplicity and efficiency in everything, from web development to artificial intelligence to data science in particular. Whether you are new to coding or refining your skills, let's break down Python step by step and explore its real-world applications. Okay, so after this particular lecture, you should be able to define what programming is. We are going to look at an overview of programming languages and the types of programming languages that we have. We are going to look at compilers, interpreters, and assemblers. We are going to look at syntax and semantics. From there, we look at a brief history of Python, the advantages of Python, where to write Python codes online or via an IDE, and then at the end of this particular series, you should have a very strong Python foundation. What is programming? At the basic level, a computer program is a set or recipe of instructions that tells a computer what to do. When a computer executes a program, what happens is it reads what you wrote or the instructions that you give to it, and then it follows it. So programming can be defined as giving a set of instructions to a computer for it to perform a specific task using a programming language. Overview of programming languages. What is a programming language? A programming language consists of instructions used to produce a wide range of outputs, like software, algorithms, and data. We could say that a programming language is a language that programmers use to give instructions to computers. So there are two main types of programming languages. You have the low-level languages, and then you have the high-level languages. The low-level languages are close to machine code, that is ones and zeros, and they are very difficult for humans to read and understand. High-level languages are user-friendly here, and then they are similar to the human language. As such, you can read them and then you can make understanding out of them. Examples of programming languages. You have Python, which is easy to learn, versatile. It's being used in fields like web, the AI, and data science. That is the focus of this particular lecture. You have Java, which is platform independent, widely used in enterprise apps. You have JavaScript, main language for web development. You have C or C++, powerful and then used in system-level program. So programming languages are the foundations of all softwares and applications, enabling developers to communicate instructions to computers. Overview of programming languages. Again, this time I'm looking at interpreters, compilers, and assemblers. An interpreter translates high-level code into machine language line by line during execution. So an interpreter basically converts high-level languages into machine code, which can be understood by the computer. Example of languages that uses interpreters are Python. You have the Ruby and we have the JavaScript. So interpreters are easier to debug, so it allows immediate feedback. Disadvantages are that they are slow in execution as compared to compilers. Okay. So let's look at compilers. Compilers also translate high-level language, same as interpreters. But this time around, they don't translate it line by line as interpreters do. Interpreters are going to translate the codes line by line. But with compilers, it does the translation at once before it starts to execute. But an interpreter will translate, execute to the line, go to the next line, translate, and execute. Okay, so advantages of compilers. It's faster in execution and it helps or provides an optimized code. The disadvantages, it requires complete translation before running. As such, it is harder to debug. Examples of programming languages that use compilers are C, C++, Java. Assembler. So the assembler is also that which translates assembly language, that is low-level language, into machine language or machine code. The purpose is to convert human-readable assembly instructions into binary codes, that is zeros and ones, that a computer can understand and execute. Example is an assembly programming for a specific hardware. Syntax versus semantics. Now, when we say syntax, syntax basically refers to the rules that define the structure of valid code in programming language. A typical example is in Python. The correct syntax for printing out or for displaying out to the outside world is by using the word print, then parenthesis, then double quotation with the string that you want to print out. So errors occur when syntax is incorrect. Example, in Python, when you miss the parenthesis for the print function, it's going to return an error, a syntax error, meaning that there is something wrong somewhere, there is something missing somewhere. Semantics. Semantics refers to meaning behind the code and how it behaves when executed. Example, print 5 plus 2 is a Python code that is used to print an addition of these two numbers. So it has the syntax print, or it has the function print, but its semantic or the meaning behind it is 7, because basically what will happen is that the interpreter is going to add to this two number, which becomes 7, and the print function is going to bring this out as such. The meaning or the output is going to be 7. So errors occurred when the code's meaning is incorrect, such as using a variable that has not been defined. Key differences between a syntax and a semantics. So a syntax is the structure of the code, that is the grammar, and the semantics is the meaning or behavior of the code. Brief history of Python. Python was created by Guido van Rossum. The initial release was done in 1991. Okay, so Python was conceived as a successor to the ABC programming language with an emphasis on readability and simplicity. So key features of Python include easy syntax, designed for readability. It's an interpreted language that works across different platforms. It also is an object-oriented programming language and then has high-level features. Python also has a very strong community and an extensive library ecosystem. So major milestones in Python. In 2000, Python 2.0 was released, introducing important features like garbage collection. In 2008, 3.0 introduced improvements and some backward incompatible changes. Python is still evolving as time goes on, with regular updates, introduction of new Python packages or libraries, and other enhancements. Advantages of Python. Python or programming in Python usually feels like using a human language. So for example, you have the word or the function print. Print is a human language that almost everyone understands. It shows that something is being outputted. So that is how Python is. Python is very user-friendly. It is simple and it has readable syntax. It's easy to learn, write, and maintain the code. It's versatile and cross-platform. Here we are saying that Python works on multiple platforms. It could work on Windows, Mac OS, Linux. It has an extensive library and a framework. So it has a very rich ecosystem for web development, for data science, AI, automation, and many more. It has very strong community support. Here we are saying that Python has a very strong or active user community and abundant resources and tutorials are open source projects. So here what we are trying to say is that there are a lot of users using Python over the world. So every problem that you face, someone has already faced it. As such, how can guide you solve that problem or getting past that problem? It's very simple. Python is an interpreted language, as mentioned earlier. It executes codes line by line, simplifying, debugging, and testing. It has a dynamic typing, that is, it allows flexibility in coding and faster development. Python is great for rapid prototyping. It is ideal for quickly building applications and ideas. Integration friendly. It easily integrates with other languages like C++ and Java. Where to code? So there are different or variety of areas that you could code in Python. You could follow this link to the Python org to use your shell to code. You could also there are a lot of interpreters online that you could use, and then Example of these interpreters are here. In our next videos, we will be looking at how you'd access all these slides, and I'm going to share the links in the description of this video. Another another platform for coding is what we call the IDE, which simply means Integrated Development Environment. An IDE is simply a software application that provides tools and features to help programmers write, test, and debug code efficiently. Examples of Python IDEs are PyCharm, VS Code, and Notebook.